Hello, I'm going to make a little video here to help you get started on our first experiment. So here we are on the home page for our Canvas, and these are messed up, don't know why, doesn't matter. Here in the yellow, you'll notice I changed this from the first week. This is week 2. You should be here, chapter 2. So when I click on that, it'll take me to the chapter 2 module, which is what you should be working on right now. And then if I look at that, it's all grayed out here, and there's a lock here. Because this is locked, I haven't finished chapter 1. So I'm going to look through chapter 1. I see some check marks. I haven't finished those assignments and submitted them, but that's not going to keep me from going on. But this circle here, I didn't do that one yet. I didn't mark it as done. So I need to visit this page. Those are the instructions and the link for the chapter 1 quiz that opens at noon on Thursday, and you need to finish it by midnight on Friday. So what I want to do here so I can go on is I want to click the Mark as Done button up here. I'm going to click that, and then I could go down here and click the Next button, and that's taking me into chapter 2. So here's the preview for chapter 2. I want to work on the experiment. I forgot to remove this, content coming soon. It is here. So I can click on that, and that will take me to experiment 1. So there's a lot of words here, and I've tried to make it as clear as possible, but I'm afraid it still needs some explanation. So anything that's highlighted in blue, that's kind of background information, background instructions. So how to get your lab notebook ready. And then I have this document here, instructions for laboratory notebooks. And the really important part of that, of course, is at the end. Right down here, what you should do with your lab notebook, how you should get it ready to use. So you're going to put your name on the outside, etc., your name on the inside. You're going to number the pages and start a table of contents. I highly recommend taking table 1, which is just that one up there, and copying that and pasting it into your lab notebook. And then this is instructions on what to do for each new experiment. Once you've looked at that, then we can minimize that file preview. We don't have to look at all of that anymore. So then here are the experiment instructions. Write the experiment name and title at the top of a page. We're always going to start a new page for an experiment. Read the introduction and background sections. They might not make much sense. Do it anyway. You're going to need to look back at those. Read the procedure. And then I've inserted the video clips into the procedure. So as you read the procedure, you're going to see video of me doing the experiment. And then you're going to need to record data, sometimes observations. Those things should be recorded in your lab notebook using ink, not pencil. You'll make a mess sometimes. It's okay. The notebook is for making messy stuff in. You should always label your measurement. So instead of just writing this number that you got from the balance, identify it, label it. The mass of the beaker was this. There are some calculations you're going to need to do. I recommend doing those in your notebook. You should always include all of the units and use dimensional analysis wherever possible. And I will be docking you points if you don't do that. After you finish going through the procedure, then you'll fill out the report, and there's more instructions in blue down at the bottom for that. Okay, so now I'm into the actual experiment. In a face-to-face class, this is a document that you would print out and bring with you, but I've just put it all into this page, so because we're just going to read it, we don't need to print this out. So here's the introduction, introducing you to the experiment. Here's the background section. So the first part talks about accuracy and precision, what the differences are, how we can measure those. And I highlighted some things that I think are particularly important. There's some important equations here. Here's the equation for percent error. You're going to need that later. Down here, then, we're talking about precision. Precision can be quantified using standard deviation or relative standard deviation. So standard deviation is calculated using this equation here, But notice what it says down here. Do not use equation 3 to calculate standard deviation by hand. You need to use the stats function on your calculator. Doing it with equation 3 is very, very tedious, and you're most likely going to mess it up. We're going to do lots of standard deviations. You need to learn how to use your calculator. Percent relative standard deviation is just the standard deviation divided by the average times 100. We've talked about rounding calculated values. How do we round a standard deviation? There are different methods for doing that, and this goes over some of the reasoning for that. Bottom line is down here. Mrs. K says, round the standard deviation to 2 significant figures, and then round the average to the same decimal place. This is probably including 1 extra digit, but I'd rather do that than lose things. Then it talks about rejection of outliers, because sometimes in a set of data, there's a point that doesn't seem to belong. We can't leave that out of our average or whatever just because we don't like it. We need an objective way of rejecting the outlier. So in Chem 1A and Chem 1B, we use what's called the Grubbs test. And this is the Grubbs test calculation here. You're going to calculate this experimental Grubbs value using the suspected outlier and the average and the standard deviation. Then you're going to compare that to the critical value. The critical value is listed here, and it changes depending on how many values you have. So if you have 4 numbers that you're averaging, you're going to use this critical value. And then it goes through a worked out example. Here they had 10, and the critical value was 2.176. The experimental G value was 2.198. This was larger, and so then you reject the outlier. When you're looking for an outlier, you're looking for either the highest number or the lowest number. So here the highest number is 17.24. The lowest looks like 17.14. The outlier is whichever is furthest from the average. Sometimes that's pretty easy to tell, otherwise it isn't, other times it isn't. It never hurts to do both the highest and the lowest and just report the one that's largest. So that's all background information. And here's the procedure. So in this experiment, we're going to measure 10 milliliters of water with different pieces of glassware, and we're going to see how accurate and precise the different ones are. So determine the mass of a clean, dry 100 ml beaker. This is our weighing beaker. And here I've highlighted this. Always record masses using all of the digits displayed on the balance. Now in a face-to-face class, you would actually be in the lab and you would go do that. Unfortunately, we can't, but we have a video. So you click on this, you can make it larger if you want, press play. There's no sound on these. You can just watch what happens. So there, I zeroed the balance. With the doors closed, I put the clean dry beaker inside, close the doors, wait for it to stabilize, 50.5053. So that is a number that you're going to record in your lab notebook. Next step, using a 10 ml graduated cylinder, measure out 10 milliliters of DI water, that's distilled water, deionized, as closely as possible and pour it into the weighing beaker, then reweigh the weighing beaker. Oh, I missed a step up here. No, I didn't. Never mind. That comes later. So we can watch that video. Okay, so super exciting. The nice thing about this is you can rewind them, you can watch them in slow motion or fast motion, empty and dry the weighing beaker, and then repeat for 2 more trials with the cylinder, and then we did 3 trials with other pieces of glassware as well. Here's taking the temperature of the water. Honestly, I forgot to do this, and so I found this picture on the internet. So you're going to look at this, and you're going to record the temperature. And it says, don't forget to estimate 1 decimal place beyond the markings shown on the thermometer. So when you record your temperature, make sure to do that. Then you need to look up the density. And so here is the cover of the CRC, and that gives you information you're going to need for the reference. And here's the page that we're interested in. And I wrote on here and highlighted. So this is the water temperature. Here is the density. It's given in kilograms per cubic meter. So you're going to look up the temperature, and just these are by whole numbers. So pick the one that's closest to the temperature you recorded. And this, it's in here somewhere. That's your density. Write down all the digits. Next is an experiment with pennies. The sizes of these pictures keep changing. So there's 8 pennies dated post-1982 and 1 that's pre-1982. Pre means before, post means after. And so I've numbered these 1 through 9, and then I recorded their masses. And so in this video, I linked the wrong video there. I have to fix that. In the video that will be linked there, you'll see me weighing the pennies, and you can record that. So then there's calculations that need to be done with the volume measurements, with the mass measurements. And then here are instructions on how to complete the report. So I'm sure you're going to have a lot of questions. Please ask me. If you're not sure what to do, always ask. Okay. See ya.